Hey there, today we're going to be looking at chapter 4, all right? We're going to be starting chapter 4 today, and the first part we're going to be looking at is section 4.1. And the first part of 4.1 will be kind of delving into the idea of radian and degree measure, okay? So we have some little fun facts here about trigonometry, but let's just kind of dive right in. You guys can read this at your leisure. But let's talk about angles because that's really what we use radian and degree measure to measure is angles. An angle is formed by rotating a ray about its endpoint, okay? So what you can do is you take the ray and then if you were to kind of like rotate it kind of with that fixed point, that's what creates the angle. When we talk about an angle in standard position, we talk about an angle with its initial side on the x-axis, okay? It then starts here and then it kind of stays put on the origin. It can rotate about somewhere else. And then that's where the ray ends up. And that's what we call the angle measurement. When you draw angles, you should have 3 different parts to those angles. Make sure that even though it's along the axis, I do think it's important to draw the initial side. Of course, I would draw the terminal side as well. And the other thing you need is this direction of rotation. So that direction of rotation tells us that it tells us that this is the initial side. The arrow tells us that it went to the terminal side, okay? So again, angles in standard position, that means the initial side is on the positive x-axis. When we talk about coterminal angles, and we'll kind of delve into that in a little bit, when we deal with coterminal angles, they have the same initial and terminal sides. So what that would mean is that like a coterminal angle would start here at the initial side, and then it would still end up at that terminal side, okay? So that is a coterminal, sorry, someone came in. That is a coterminal angle because notice it lands at the same spot. Notice to land at the same spot, you have to go around another whole circle. And so we'll talk about why this is later. So you guys are probably more familiar with the idea of going 360 degrees for a circle. But what we're going to look at and really focus on is this idea of radian measurement, which means that a full rotation is could also be considered 2 pi radians. Okay, so coterminal angles are found by adding and subtracting 360 degrees or adding and subtracting 2 pi. Another important piece is the idea of the signs of the angles. A positive angle is when we go counterclockwise, okay? And a negative angle is when we go clockwise, okay? So if you think about an old-fashioned clock, the kind that I grew up with, that's what we mean by counterclockwise. Sometimes we'll say CCW for the positive angle, and then clockwise, just CW for the negative angle. I'm going to start by talking about radian measurement instead of degree measurement because radian measure is really the preferred and expected measure, okay? Again, if you see like a 2, that's understood to be 2 radians, all right? Like radians don't even need you to write the radian as a unit. It's understood to have that as a unit, all right? So when we talk about the measure of an angle, it's determined by how far it rotated. It's determined by the amount of rotation from the initial side to the terminal side. And one way to measure angles is in, oops, this got cut off, is in radians. Okay. The reason we focus on radians is because this type of measure is especially useful in calculus. To define a radian, we use a central angle of a circle, one whose vertex is the center of a circle. And what a radian is defined by is when, it's not like a triangle, but it's when you have two radii that form an angle and this arc has the same length as the radii, okay? So that would mean that like if this radius is length 1, this radius would obviously be length 1, and this length would also be length 1, okay? But this angle that causes that to be true, like it causes this to be congruent to this, to be congruent to this, whatever angle that is when that is considered 1 radian measurement, okay? And so notice that we have 1 radian, 2 radians, 3 radians, and notice that right here is a little more than 3 radians, and that little more than 3 radians is actually a very special number. 1/2 of a rotation is considered pi radians. Notice it's a little more than 3. Actually, it's about 3.14. So therefore, if this is pi radians, if this is 1 pi, then if we go around again, this is considered 2 pi radians. Notice it's a little more than 6. This is about 6.28. So that would mean that what we think about in degrees, so like a quarter of a rotation would be pi over 2 radians, which is about 1.57. And that if we went 1.5, well, okay, I guess so 3/4 of the way around, sorry, I'm always thinking in terms of pi when I do these, then that's basically 1.5 pi, 1 pi, and then 1/2. So 3/2 pi, which is about 4.71, okay? So when you see 2 radians doesn't mean 2 pi radians, okay? So 2 radians really means that you would end up here, whereas 2 pi radians means, I'll use a different color for 2 pi, whereas 2 pi radians would mean that you would end up here, okay? So notice that 2 is not the same as 2 pi. That's just kind of something important going forward. Just one big piece when you're thinking about measuring in radians is that basically 1/2 of a circle is 1 pi, okay? And that one full circle is 2 pi, okay? So 1 full revolution means that we have 2 pi radians, okay? So 1 full revolution is 2 pi radians. So 1/2 of the circle, 1/2 a revolution is 1 pi radian, all right? So that's kind of a little bit about radian measurement, and you've got to learn to be comfortable with that, okay? Like, trust me. So in general, one relationship that we have is that theta, and theta is just a way to measure an angle. Instead of using x, we often use theta for angles. That theta equals S over R. And in that case, theta represents the angle measurement. And if we use this, it's the angle measurement that's actually in radians. S is our arc length. So S again is like how far the measurement is. Okay, so theta is like the opening, okay, how much you're opening, the measurement of the opening. S is actually like how long it would be, like if you could take that and stretch it out, how long that would be. And R represents our radius, okay? So that's actually a definition of our radian measurement, okay? And that's what we need to be as comfortable with as possible. So let's now make sure that we look at the degree measurement as well. So a second way to measure angles is in terms of degrees, and that is denoted by the symbol with the degree, right? You need the symbol, okay? When you see, for example, 3, 3 means 3 radians, okay? and that is not equal to 3 degrees, right? So again, a whole circle is 360 degrees. So 3 degrees would be like way down here, okay? But if you look back at where 3 radians was, 1, 2, 3, 3 radians would be way over here, all right? So again, make sure that you have the unit of degrees when you're talking about that kind of measurement. So a measure of 1 degree is 1/360th of a complete revolution. And again, there are these really convenient marks that hopefully are familiar to you from last year. Things like 30 degrees, 45 degrees, 60 degrees, 90 degrees, etc. So it's convenient to mark those degrees. Again, because 2 pi radians corresponds to 1 complete revolution, degrees and radians are related by these equations. Notice that 1 full rotation is 360 degrees, which is 2 pi radians for 1 whole revolution. So this is 1 whole revolution. And then if you have 180 degrees equals pi radians, this is usually the one we use the most often. And just keep in mind that that's basically half of a revolution. And we usually use this one just because it's reduced, okay? Like when we use it as a conversion factor. So in these examples, we're going to determine the quadrant in which each angle lies. And we're going to draw a picture to help you. We are not going to convert these to degrees. We are going to think about radian measurement, okay? So this says that we have 7 pi fourths. I think it's very, okay. I think it's very convenient. I don't know if my video is working, but we'll keep going. I think it's very convenient for us to think about this in terms of like a mixed number. So like 7/4 is the same as 1 3/4 pi. And so that's kind of why the way that I think about it. So I'll draw my initial side, okay? And I want to go 1 pi. Remember, 1 pi is just here, all right? So I'm going to go 1 3/4 of the way around, okay? So that's how we would have 1 3/4 pi. Remember, this is 1 pi, and then 3/4 would be 3/4 of the way around. We should notice that that's going to land in quadrant 4. Oh, sorry. Because it was positive, I knew that I needed to go counterclockwise. So I start in quadrant 1 and I work my way around, okay? So I went counterclockwise because it was a positive angle. Let's look at number 2, negative 11 pi fourths. Well, let's turn this into a mixed number. 4 goes into 11 twice with 3 left over. So that's like negative 2 3/4 pi. So if I think about my axes here, if I need to go negative, that means I'm not going to start by going in the first quadrant. I'm going to go backwards by starting with the 4th quadrant, which means I go clockwise. So I'll draw my initial side, and I need to go 2 pi and then 3/4. So remember, this is 1 pi, 2 pi, and then here's a half, 3/4 would land right here. So that would be where negative 2 3/4 pi is located. And notice that's in quadrant 1, 2, 3. Number 3 wants us to graph 4.2. This is not 4.2 pi, all right? This is 4.2. Remember, we said that, let me draw an axis. We said that 1 pi was about 3.14-ish, right? We'll just go to the nearest tenth. It doesn't matter too much, okay? And that if we went, so we start at 0, and that would be 3.1. So this would be about 6.28, so 6.3. So then halfway between here would be about 1.6-ish, okay? and then that means that this would be about 4.7, okay? So again, here I'm just thinking like, I know that this is 1 pi, so let's cut that in half. If I cut 3.14 in half, that ends up being about 1.6. So then I can just kind of add 1.6 going around to get an idea of where 4.2 is going to be. Notice that it's positive, which means that from the initial side, we're going to go in a counterclockwise direction. And so notice that I'm going to go past 3, but not quite to the 4.7. All right, so that is where 4.2 radians lives, which is in quadrant 1, 2, 3. The last one that's like this is -240. And notice that this one is in degrees. So when we have the degrees, then we think about this as being 90 degrees, this as 180 degrees, down here as 270 degrees, and here as 360 degrees, after starting at 0, of course. And because we have -240 degrees, that means that we would want to go backwards, which is actually clockwise. So again, if you're counting backwards this way, then that means that we just kind of have these flipped. So this really we want to think about as like -90, -180, -270, and then at -360. So if we wanted to go to -240, we would go backwards to 180, but then not quite to 270, okay, in that negative direction. And we can see that that lives in quadrant 2. So again, try to think about the relationships, like use your axes as landmarks. And then again, with these values, fractional values of pi, really think about using mixed numbers and where pi would land, okay? In example 5 and 6, we're again going to sketch the angle in standard position. So it's really what we did up here, but we just don't have to tell the quadrant. So this is asking us to graph 11 pi 6. And if I graph 11 pi 6, what I can do is think about that as a mixed number. This is like 1 5/6 pi. And so what that means is that if I look at my initial side, I need to go in a positive direction, which is counterclockwise. Remember that over here is 1 pi. And so I need to go 1 and then 5/6 of the way around. So it's going to be pretty close to that axis there, okay? But that is all we need there. That's just asking us for the angle in standard position. So like that's your answer, okay? I don't know if you can happy cloud it if you want, all right? In number 6, we want to graph -3 pi fourths. And to graph -3 pi fourths. So notice we don't have to change this to a mixed number. We can think about our initial side, and because it's negative, we want to go clockwise. Remember that this is 1 pi, so we don't want, well, if we work this way, it would be -1 pi. So we don't want to quite get there. We want to go about 3/4 of the way to the other side of the axis here. And so I would say that that would be right in the middle here. And that would be the -3 pi fourths, okay? All right, great. Next, find coterminal angles. When we find two coterminal angles, remember when we have coterminal angles, that is where we're going to add and subtract 2 pi if we're in radians, or 360 degrees if we're in degrees. Do not go back and forth from one form to another. If it's in radians, stick in radians. If it's in degrees, stick in degrees. So in number 7, when I have 11 pi over 6, I want to add or subtract 2 pi. Well, adding and subtracting 2 pi, because this is a fraction, isn't going to do much good. Let's write it as an equivalent form with a common denominator of 6. How could you rewrite 2 pi with a denominator of 6? Well, that would just be 12 pi over 6. So then I take 11 pi plus 12 pi would be 23 pi over 6 if I add 12 pi 6. And if I take 11 pi 6 minus 12 pi, 11 minus 12 is negative 1 pi. Keep the denominator of 6. Those are your coterminal angles. One was positive, one was negative. Let's do the same thing in example 8. I have negative 13 pi 6. So again, I need to add and subtract a form of 2 pi that has the denominator of 6. And, okay, this one's kind of lame. I get 12 pi 6. So let's take a look at what happens when we add 12 pi 6. That gives us negative pi 6. But notice when we subtract 12 pi 6, we get another negative angle. That's not going to help us, is it? So if that happens, then just, in this case, we would just add another 12 pi 6 to help us until we get a positive angle. And here we're able to get one relatively quickly, all right? But if you end up with two angles with the same sign, just keep adding or subtracting forms of 2 pi until you get the sign that you need. Lastly, in number 9, we have something that's in degrees. So here what we would do is add or subtract 360 degrees. So if I add 360 to 155, I get 515 degrees. And then if I subtract 360, I get negative 205 degrees. And again, you could keep adding and subtracting multiples of 360 till you get where you need to be, okay? So that's coterminal angles. Again, that means they land in the same spot. All right. So here are some common radian and degree measurements that are equivalent, all right? Pi 6 is like 30 degrees. Pi 4ths is like 45 degrees. Pi 3rds is like 60 degrees. Do you recognize these from anything you learned last year? I hope so. These should be points that are common, or angle measurements that are common on the unit circle. The pi over 6, pi 4ths, and pi 3rds. And then again, we've talked about these a little bit, that pi halves is like a 1/4 of the way. A pi is a half of a full rotation, and 2 pi is a full rotation. Sometimes they would ask us to express the angle in radian measure as a multiple of pi, and that's just asking you to convert basically from degrees to radians. So one way you can do that is by using this conversion factor, this idea that of pi over 180. So we can do that with the 315 degrees. We can multiply by pi radians over 180 degrees, and then we can simplify from there. If we simplify, you end up getting 7 pi 4ths, but in this case, this is actually a special angle from the unit circle. You shouldn't necessarily eventually, at the end of the day, have to do that conversion. We would do the same thing for negative 225. I guess to start, you could multiply by pi over 180 and then simplify. When you simplify, you do get negative 5 pi 4ths. But again, as we go further through the chapter, you'll want to recognize negative 225 right away as negative 5 pi 4ths without doing a conversion. Now in number 12, notice that these are not critical values. Those are not special angles that we studied with the unit circle. But again, we can use this same conversion factor, but this time use the reciprocal so that we end up with the appropriate measurement. So this time you would use 180 degrees over pi radians. Oh, up here, notice that the degrees canceled. And notice that here, the pi's cancel oftentimes if it's expressed in terms of pi. So we would end up with 180 degrees over 9, which would be 20 degrees. Okay. When we have 12, that's kind of a different story. Notice it's not 12 pi. We would multiply by 180 degrees over pi. And so that would give us 2,160 over pi degrees. That would be the exact measurement. But if you wanted to figure out what that was exactly, you could just punch that in the calculator, 2160, use the pi key divided by 5, and then you would get this answer. We'll be specific on a quiz or test on if we would want it to be exact or not. Okay. Lastly, complementary versus supplementary angles. We know that complementary angles is when their sum is 90. The thing is, now that we've talked about radian measurement, we want to make sure that we're also thinking about the radian equivalent. So it's when two angles sum to pi over 2. Similarly, two positive angles are supplementary when their sum is 180 degrees, but now we know that that's the same as saying that their sum is pi, okay? So that's the difference between complementary and supplementary angles. So this asks us to find the complement and supplement, if any, for each angle. Like an angle might be like 130 degrees. That's not going to have a complement because it's defined as a positive angles. All right, so notice that complementary and supplementary angles have to be positive. So if you had something that was like 130 degrees, then that couldn't have a complement because it's too big. It's already more than 90, okay? So let's find the complement and supplement for each angle. So what we'll do here to find the complement is we'll take pi over 2 minus the angle measurement in question, which is 2 pi fifths. Then we would just convert to a common denominator. Oops, sorry, I don't know why I turned it. Oh, I do. So the common denominator here would be in terms of 10. So that would be like, I could turn pi over 2 into 5 pi tenths, and 2 pi over 5 could turn into 4 pi tenths. So my complement would be about pi, would be exactly pi tenths. For supplementary angles, what we do is we take pi minus the angle in question. So we would take pi minus 2 pi fifths. So if I'm writing that in with a common denominator, that would be like 10, wow, that would be like 5 pi fifths over 2 pi fifths, which would be 3 pi fifths. So that would be our complementary angle, and that would be our supplementary angle. So that's pretty much the rule that you use. The same would be true in number 15 with this 1.3. This is not 1.3 degrees, this is radians. So once again, to find the complement, what we would do is take pi over 2 and then subtract 1.3. So that's not going to be anything super pretty. Notice that we could just take pi over 2 and then subtract 1.3, and that gives us about 0.271. Again, we usually round to the nearest thousandth. And to find the supplementary angle, again, we just take pi minus 1.3. Again, supplements add to 180. And remember, pi is like 180. Just kind of keep that in your head the whole time. Oops. So I'm going to take pi minus 1.3. And that gives me about 1.842 if I'm rounding to the nearest thousand. So this is my complementary angle, and this is my supplementary angle. It's weird to have angles without a unit, isn't it? But again, that means 0.271 of a radian. Remember, a radian isn't a tiny degree. A radian is much bigger than a degree because we only need about 6.28 radians to get around a whole circle, but we need 360 degrees to get around a whole circle, okay? And that is kind of what I'd like you to start working on in chapter 4. That's it. You guys have a wonderful day. Don't forget your bookwork.